right. Thank you everyone for joining me today. Today we'll be talking about automating legal document extraction and review. But before we dive in, just a little bit about myself. So I'm a software engineer by trade, and I kind of came up, through various kind of technology consulting companies, kind of accumulating some different technologies along the way. But currently my role at PwC is a partner within our products and technology group, kind of enabling various business segments in terms of the technologies that we're using to help bring our PwC services to market, and also some of the commercial products that we're taking to market. I actually fell into the world of data science and machine learning about 5 years ago. At that time, I was starting to help lead our AI lab within PwC Labs. And that really kind of sparked all my passion for everything natural language processing, machine learning, and all things AI. Since then, I kind of started on this journey to complete my master's of data science, only 12 weeks away from completing that at the University of California, Berkeley, for my master's information data science. So very passionate in this area, also very technical in this area. And in fact, I'm a US patent holder on the recently approved patent for a continuous machine learning method and system for information extraction, which is some of what I'll be talking to you all about today as well. So you'll get a little bit of a deeper dive into some of the techniques used behind that patent. So that's a little bit about myself and my role at PwC. So look forward to jumping into the content here. So I guess, if you think about the title of this session, the question is why legal, why NLP? If you're not close to the legal profession, you may not kind of understand all of the happenings that are going on in kind of the legal industry, just kind of more broadly. If you look at it, a lot of departments are under a lot of pressure to deliver more with less. There's constant regulatory changes that are coming about, new tax rules and legislation, and all these other things that impact the way that companies contract with other companies, the way companies do business with other companies. Also, if you think about, the world in which we work into, companies are under a lot of pressure too for diversity, equity, and inclusion. That also goes back to employment contracts and things like that. So legal is kind of in the midst of, really feeling the pressure of all the change in the economy and the regulations and the human capital and workforce. So legal plays a critical function in terms of, helping businesses succeed. And so if you look at a lot of the work that law departments do, you can envision, again, kind of working closely with procurement on legal contracts, just in terms of how they're engaging with technology vendors, and helping shepherding those things through for the business, or, helping with deals related assessments in terms of, inspecting rental property agreements, looking at employment agreements and other things too, to help kind of assess the mechanics around a deals transaction. So legal is kind of in the middle of everything. And if you look at kind of some of the more rote tasks that you can automate from a corporate law department perspective, this is where NLP and machine learning really come into play. So you'll see a boom kind of happening in the legal tech market, which is a $16 billion plus industry at this moment. The legal services market is also very rapidly growing with law firm services, and also different services that companies like a PwC or the Big Four kind of bring into market. And then if you look at the natural language processing market, that's booming as well. So you've got legal booming, you've got legal services booming, you've got natural language processing booming. So it's a good time for NLP in the legal space. So what do we actually mean by using natural language processing in legal? So kind of what I was alluding to a little bit earlier, if you think about a lot of the involvement that happens with having to manage contracts from a legal perspective. A lot of companies, even though they might have implemented CLM, ELM systems, so contract lifecycle management, enterprise legal management systems, there's still a lot of work that actually happens outside of those systems in terms of how the contracts are actually redlined, and finalized before they ultimately get uploaded into a CLM, or a client may not have a full CLM implementation yet. And so you've got a lot of these PDFs floating around with, all these contractual commitments, whether it be to vendors, to suppliers, et cetera. So there is, a lot of what we've kind of seen over the past couple of years, and in my profession, your clients still have kind of a burning problem to address in terms of how do I digitize all my legacy contracts, whether that's migrating into a new contract lifecycle management system, whether that's just kind of helping with a deals related assessment from a mergers and acquisitions perspective. So NLP and machine learning is perfect for this task within legal. And so there's a lot of different, approaches that we kind of see out there today in terms of, how you're extracting information from documents or legal documents using natural language processing and machine learning. But if you look at the complexity of the problem, there's a lot of variation in all these different types of contracts. And so you can see some of the images here on the slide here in terms of different structures of text with different types of legal contracts. So legal contract can span, again, NDAs, master service agreements. If you look at loan agreements, purchase agreements, employment agreements, vendor supply contracts, invoices, bill of lading, purchase orders, like there's all these different types of documents. So what is an approach that you can take to provide a consistent way to extract information from these different types of documents, all having these various different structures of text? Because like what you can see in here, some may appear to the human eye as very structured tables within the documents. Although that appears great to the human eye, what does that look like to computer vision? But then also, if I'm trying to pinpoint a specific piece of information within a table structure, how do I go about doing that in a consistent way? Or if I've got heavily unstructured text, so how do I take a consistent approach to really extracting information from all these various different structures of text? So that is really the problem that we're talking about. So the answer is there's no silver bullet, and you kind of have to take a multi-pronged approach. So if you look from structured all the way to unstructured, there's different techniques that you can apply to really help address kind of the problem end to end. So if you think about kind of more of the structured data, that's where you kind of might more take like a templated approach. So there's various solutions in the market that provide you the ability to kind of create these templated layouts to help extract information from documents. But then as you start to get into more of the semi-structured, where now you're dealing with some structured elements, but some unstructured elements, now those templated layouts probably won't give you everything that you need to help you extract that information out. And you might find yourself also kind of managing a lot of these different templates to be able to handle extraction from those various documents. So that can become burdensome in terms of the amount of templates that you need to create and manage and support over time. If things are constantly changing in terms of like the structure of the document or the structure of that contract or legal document, then the template approach probably isn't going to get you everything that you need long term. So that's where you really need to get into more of a machine learning based approach to help with the extraction of the information off the documents. So depending upon kind of the homogeneity of the document, you'll be taking maybe one or other approach in terms of if it's more structured, you might take more of a layout based approach. If it's heavily unstructured, or you've got a mix of structured and non-structured data within the document, that's where you start to introduce machine learning. And then, how do you continue to learn from the data over time as you're extracting the information from all of these documents? So as we think about that multi-pronged approach, what we'll focus on today is more of the machine learning, based techniques, hence the NLP Summit. So although you can kind of still run a full pipeline with, template-based extraction, and you can also do that in combination with a machine learning based approach. So that way you can kind of bring a full pipeline together, but we'll talk about the machine learning side here today. So with that being said, if you think about like a common process for training machine learning models for information extraction, it really starts with the quality of data in terms of how you're annotating documents to really train those machine learning models to extract information from those documents. So I think it goes with the good old saying of garbage in, garbage out. If you have bad data annotations in terms of how you're training the models, well, you can't expect those models to perform well if you're not feeding it consistent data annotations to train the machine learning models. So again, like there's this focus around quality as it pertains to how you're annotating the documents. So what I'm showing you here is related to the patent that I mentioned earlier. And so it starts with that annotation experience. So we typically call this the left-right screen in the sense of you've got the document on the left, you've got your data model on the right in terms of what you're going to use to annotate the text within that document. Obviously, before you can even start that annotation process, the document has to go through OCR to digitize the document so that you can actually start selecting the text within that PDF viewer so that you can actually start to derive those annotations for training the models. So if you look at the screen here, you know, what's unique about the patent is that basically all those labels that you see on the right are essentially, they're labels associated with a data model, but behind the scenes, what that's doing is it's training a machine learning model by label. So if you think about training a model on extracting a party or a termination date or some other type of legal clause in a document, what's happening behind the scenes is every data annotation that you use by selecting that label to annotate with, that's actually going to train an independent machine learning model behind the scenes using online learning techniques or continuous machine learning. So with that process, essentially, if I've got 15 things that I'm looking to extract off this legal document, whether it's parties, dates, different clauses, liability caps, and other things, I'm going to get 15 machine learning models that get trained behind the scenes, which also provides the ability, if I have generic things like a party that I'm trying to extract or termination dates, which are very common in a lot of legal contracts, I can actually reuse those models across different document types as well. So that's the benefit of training this plurality of machine learning models all through a single annotation interface so that you get the benefits of those independently trained machine learning models at the term level, so you can reuse that across different document types, which we see a lot of those use cases in the field today. And this approach has been extremely beneficial in terms of helping accelerate the use of using prior learnings on different document types or extracting information from never seen before document types. So if probably the other thing to mention here too is this screen here too. As you look at it, it's meant for the initial annotation process, but then also like as you think about the review process that has to happen too. So once I train these models, I load in my next batch of documents, and the models start making predictions. This screen is also used for a reviewer to actually come through and review the predictions from the model so that they can either reject or accept those predictions. So if they're rejecting the predictions as a reviewer and saying, no, that's not quite the clause I intended you to identify, they can delete those annotations or those predictions, select that label, re-annotate, and then that will kind of be used as the next training batch for the machine learning model, just so that we don't keep getting those bad predictions from those individual term-based models. So I think to summarize here, so again, like this, it all starts with this annotation experience to make sure we're driving a consistent process in terms of how the documents are annotated, which again leads to more reliable annotated data. So we have good data going into that continuous machine learning process so that we have a better chance of having more accurate models to identify and extract the information out of the documents. The other benefit of this too, and as you think about the extractions as they're reviewed and coming out, is that now that I've got all this data extracted, I can do a lot of different things with it. I can pump it into those CLM systems to help with contract migration. I can use other citizen-based tools to help, kind of do further massaging of the data, visualization tools to do an analysis against that data in terms of, what's my spend by vendor, or what are the termination dates that are coming near that I need to proactively be aware of. So there's a lot of benefits too in terms of how you're digitizing these contracts, using natural language processing and machine learning. So that's about kind of the upfront annotation experience, again, to make sure you've got that good data coming in to help with the success of the training and the overall quality of the information extraction models. So kind of sitting behind that, now we go kind of a layer deeper. This layer deeper is the plumbing that kind of sits behind here. So I mentioned earlier, again, you can kind of have this whole pipeline, right, that combines, templated-based extraction with machine learning-based extraction. That annotation interface that I showed you just a minute ago, that was more focused on the machine learning side. But if you look at also the ability to kind of combine all these things together, that really brings a unique machine learning or kind of overall information extraction pipeline together as well, where you can run the OCR process. From there, you can either, from a configuration perspective, execute some of the initial template-based extraction, where maybe you've got a front page of a contract that might be more structured, or even if you get into tax forms and helping with deals assessments, you might have that first page of the document is more structured, so you execute that template-based extraction. Then for anything that kind of follows where it's less structured, then you can kind of invoke the machine learning process to execute all those machine learning models that were trained from that data annotation process I just showed you a moment ago. So as you think about all this from a machine learning perspective, so the annotations that we're kind of talking about for those individual term-based models earlier, essentially what that looks like kind of behind the scenes is those are all JSON documents. So if you think about how the text is being selected in the annotation screen, you get kind of those coordinates for that bounding box, right, in terms of where that text actually sits within the document, coming out of that OCR process. So you get coordinate information in addition to the text. There's other things that you can do too in terms of other features you might pull from around that annotation. So if I'm selecting a clause, for example, and within behind the system, I noticed that within the OCR, I've also got bold font, above that section for which might indicate a title of that particular section, or underlining of the text, that might be kind of above the section that I've highlighted too. So that annotation process is doing multiple things. It's not just grabbing the text, grabbing the bounding box coordinates, if you will, for the text that was selected, but it's also kind of doing looking around kind of the text selection to see if there's other features that can help in terms of, maybe there's a potential table border that also kind of sits around that general text that we've kind of seen from the OCR output, or if there's title or bold font text, kind of sitting above that from a document coordinate perspective. So essentially the JSON data kind of captures all that information from the OCR output, plus what the human just selected from a location perspective. So that is really kind of the core features that, are captured within that JSON document. Those JSON documents, so we use Microsoft Azure for our solution. So this is why you see the reference to Azure Data Lake Storage Gen 2. But it could be any cloud provider in terms of, how you're just storing these JSON documents on general blob store. But essentially what we do is we kind of write out the annotations from a JSON document perspective, which again gets associated with that specific term model that was trained. And so now at this point, we've got the annotation sitting on blob store. At this point, I'm going to invoke, like once I have enough batches accumulated, our system allows for, we can kind of configure it to say, hey, 15 annotations is like the minimum. once we get 15 annotations, we'll trigger the continuous learning process to generate that next model binary. Or if you've only got 10 samples that you could work with and you want to do the retraining, click a button, kind of push it through. But essentially, what that pipeline is doing is it's picking up those annotations from Blob Store, pushing that through the machine learning pipelines again to generate that next model binary, which is again training a learning function as it relates to that machine learning model. When you think about our machine learning pipeline, so everything is kind of containerized images running on, whether you're running that on a Kubernetes infrastructure or some other infrastructure that allows you to run container images to really kind of help scale the compute on top of the data storage. So all of the models, as we think about our model pipelines, those are all containerized images. What's nice about this too is that it's a YAML-based configuration. So if, for example, I just said, hey, I've got maybe 5 annotations for this particular label, 10 for this other label, 20 for this other label, I want to go ahead and force the training process to update all those models based upon this certain type of legal contract that I'm looking to extract information from. It'll now trigger the retraining across all those individual models for which I have those updated annotation batches ready to go for. So it's kind of going through and it's using this YAML configuration file. So as you're kind of setting up, the data model within that annotation experience, what it's doing is we've got a YAML file that's kind of being updated there behind the scenes. So that way, when we invoke the training process, it knows that, okay, these different models binaries are associated with this particular document data model. And so it's going to invoke that training process dynamically behind the scenes for all of those different term-based models. So that's kind of the uniqueness too here in terms of the continuous machine learning pipeline, which is all dynamically driven based upon starting with that annotation experience and then getting basically the dynamic update to the YAML config to help the machine learning pipelines understand what needs to be trained on or what needs to be inferenced against from a machine learning perspective. So that's kind of like the details around the pipeline. The question I always get to is, so you guys just using BERT behind the scenes, GPT-3, like what like big language models are using? Oddly enough, we're not really using any. If you look at trying to train machine learning models on kind of a net new domain, which in this case is very legal centric, you got to be careful with these larger language models, like when you're performing named entity recognition or information extraction tasks, because, again, these models are only good as the data they're trained upon. So although it might sound good to have all these models trained on like all this text available on the web through web scraping mechanisms or other data sources like, media sources, for some of like the BERT-based models and things like that. It sounds good, but actually what we've seen is that can hurt model performance and actually takes more data to overcorrect the biases based upon the other data that those models were trained on. So we've tried out a couple different things. I think, BERT and GPT-3 and all those things are very good for other specific tasks. I think just kind of what we've seen for NER and information extraction, we're getting better results with more simplified techniques. Like if you look at conditional random field, again, which is using kind of some more of those features around the text that you're kind of setting up as you're setting up that CRF. And so we haven't seen a large need yet for BERT or some of the larger language models. The other thing here too is when you talk about scale, we process over tens of millions of pages on the infrastructure using these continuous machine learning pipelines every year. And so when you think about the cost to run all of this stuff at scale, over a long period of time, if you're using these larger language models, and there's Distilbert, and they've done some optimization to reduce the overall size of those language models to help with overall performance in terms of production inferencing, to help with model training. But if you look at really the scale that we're talking about too, like if you're still using some of these larger language models versus a CRF, I mean, you're your training time is still, can get up to like 10x more than what you would typically expect training time with a kind of more standard approach with like a CRF. And then on the execution side, although the execution side, gets a little bit more comparable, but we still see, 3 to 4x kind of speed up with some of the more simplified language models, again, just because the model binaries are smaller, the embeddings are smaller, things like that. So we're getting kind of optimized production inferencing time with kind of more of these simplified techniques as well. So that all being said, I think, not to say that you couldn't use some of the larger language models for this, but in terms of kind of what we've seen in the legal domain and just with the specific types of documents and legal contracts that we're dealing with, we found better success both kind of from a model performance and accuracy perspective. So with the precision recall F1, with some more of the simplified techniques where, it only takes like 30 or so samples to actually get some pretty meaningful results. So we've seen some good things there in terms of, time for training and speed ups with that for the simplified approaches, but then also just, again, how you're managing the overall cost of the infrastructure over time. So that's a lot of the lessons that we kind of had around, the plumbing behind all this continuous machine learning based approach for information extraction. And so with that being said, I mean, hopefully you guys found value in what I covered today. Again, feel free to look up that patent number too, if you're interested to kind of learn more details about that again. But thank you again. Again, my name is Jake Wilson, principal at PwC in our products and technology group, helping support our legal business solutions. So again, thanks for the time. Bye.